Today we are visiting Epic member Lyocon. So you have so many applications for your laser technology, and from what I understand, you're able to do this because of your fundamental architecture. Can you tell me a little bit how we can go from laser marking to removing hair to solving dental problems?
Let's say what is our main skill is to handling laser beam. Doesn't matter whatever they come from. So we can handle laser beam coming from a laser diode or from DPSS system or a fiber laser, whatever it is. We have skill and experience in developing also DPSS and fiber laser system. So this gives us all the flexibility and all the experience, the necessary experience, let's say, to develop not a single device, but to develop an architecture, an optical architecture. We have here three main different optical architectures that allows us to customize the single architecture to realize different kind of product. Always with the focus to develop systems that can be produced for high volume.
So you're always thinking about not building a single one-off. You're always preparing to build for high volume. So
it's correct.
Looking at this, because you're solving many problems, I'd love to point out this device because I have high interests here. So from what I understand, this laser is used in dental applications?
Correct. This is a laser module for coupling a single emitter source with many different wavelengths, starting from the infrared to visible wavelength as well, like blue, like green, like red, depending on the application, the final application.
So that affords a lot of novel, useful, effective dental treatments. Now, from what I understand, there can be a problem with implants.
Correct.
And we have an aging population in Europe, so implants are more and more prevalent.
Correct.
So can you tell me about how I'm able to use laser light to cure an infection?
In that case, it's not that a module, but we developed a special system that was a full DPSS system.
Okay.
So it's a passive Q switch with very short pulses, 3 nanosecond pulses, that allows with the high peak power to treat the implant area without damaging the implant itself, but even better, by cleaning the surface of the implant without rising the temperature of the implant. That could be a problem. For
so let's say the surface has a biofilm implant.
Yeah.
You're able to remove the biofilm without raising the temperature.
Yeah.
Now, from what I recall, weren't older systems using like some type of flash lamp laser that would ultimately heat up the metal component?
Yes, this is the main problem because you use the same system that you can use for weld metals. And you use it
in someone's mouth?
Yes, correct.
And you mean, so this metal would heat up. And what was the result of that?
That you can have a problem of necrosis of the bones due to the high temperature of the implants.
Bone necrosis?
Yes, correct.
And your system, if we treat with your laser, we don't have bone necrosis?
Correct, correct.
Which leads to improved quality of life and better health outcomes?
It's correct. You can have the same result in terms of, let's say, get rid of the infection, but without the side effect, the bad side effect, due to the increases of temperature or to damage of the surface of the implant itself.
Photons solve so many problems. Epic members drive the photonics revolution.